Hi guys. Hi guys. Unit 2, assignment number 9's notes. Solving for missing lengths in similar triangles. So we're going to go over two examples here where we are going to solve for missing lengths in similar triangles. And here is the big idea that we are going to be going over here today. So the big idea, I'm going to talk about this here. And we're going to apply this big idea to help us solve for missing lengths when we have similar triangles. Okay, when two triangles are similar, this means all proportions, all ratios will be in proportion. So the big idea is when two triangles are similar, all the ratios will be in proportion. Okay, now if you forgot what that word means, that word proportion, all proportion means is that you have one fraction equal to another fraction. So an example of a proportion would be the fraction A over B is equal to the fraction C over D. Okay, remember, ratio is a fancy word for saying a fraction. And when you have two fractions equal to each other, we call that a proportion. And the way that you solve a proportion is you're going to use that cross multiplication technique. Okay, so we're going to use that same idea here because the big idea is that when two triangles are similar, this means that their ratios are going to be in proportion. Okay, now, just for clarifying sake, I'm going to refer to the triangle on the left as the original triangle, and I'm going to refer to the triangle on the right as the new triangle for both number 1 and number 2. So that means when I write my ratios, I'm going to put the new triangle's values in the numerator, and I'm going to put the original triangle's values in the denominator. Okay, so the first thing that we're going to do is we are going to write ratios. Okay, because if you notice in number 1, it tells us that triangle AET, so AET, I'm going to color code the sides to make this easier, is similar with triangle GPI. So notice AE side, the first two letters I did in yellow. So that means in the other triangle, the first two letters, GP, that means that side is going to correspond with the 3. So the 3 and the N are going to correspond. Notice the blue side is the letters E to T, which are the second and the third letter in my statement. So that's going to correspond with P to I, the second and the third letters in my statement. So the 168 is going to correspond with the 7, and then the T to A, which is green, which is the third and the first letter, is going to correspond with side I to P. Okay, so I'm going to set up my ratios, my corresponding ratios. My new triangle's sides are going to go on the numerator. So I'm going to go N over, and the side where the N is on in the original triangle, it corresponds with 3. So one of my ratios is 10 over 3. And then my other ratio is going to be 168 from my new triangle over, and 168 corresponds with 7 in my original triangle. Okay, and then I'm going to apply this big idea. When two triangles are similar, I know the triangles are similar based on this statement right here, right next to number 1. This means the ratios will be in proportion, which means the ratios will be equal to each other, and I'm going to use that proportion to solve for the missing length, which is N, and I'm going to use the cross multiplication technique. So I'm going to multiply the 7 with the N. I'm going to write down that result, which is 7N. And then I'm going to cross multiply the other way. So I'm going to multiply the 3 with the 168. And off the screen, I'm cheating a little bit. You cannot see, but I'm using a calculator. 3 times 168 is 504. I'm going to write that result down. And then remember, when you are solving a proportion, after you cross multiply, you set the two results equal to each other, and then you use algebra to solve. So I'm going to divide both sides by 7. 7s will cancel out, and I get n is equal to 504 divided by 7, which is 72. Okay, so what I have done here is I have solved for the missing side in the two similar triangles by using that big idea. Let's go to number 2. So in number 2, same idea. My original triangle is going to be triangle APS. My new triangle is going to be triangle QOT. And you can see right here, number 2, I'm given the statement that triangle APS is similar with triangle QOT. So I'm going to solve for the missing length, which is M. So let's color code the sides to see which sides correspond. So the first 2 letters are A to P, which is 8. That's going to correspond with the first 2 letters Q to O, which is M. So my ratio that I'm going to write is M over 8. Okay? My second and my third letter in my statement for the original triangle is PS. So I'm going to highlight that in blue. Oh, that's going to correspond with side O to T. So I'm going to correspond with that. So that means the 92 corresponds with this side right here, which does not have any value at all on it. So I cannot make a ratio with 92 because I've got nothing to compare 92 with. So this 92 right here that you were given, it's actually extra information that was just put there to try to confuse you, but it's not needed. Okay, let's go to the third side, SA, which if you notice is the third and the first letter in my statement. So that's going to correspond with side T to Q, which tells me that 108 corresponds with 24. So my other ratio is going to be 108 over 24. So the big idea is that when 2 triangles are similar, their ratios are in proportion, which means they're equal to each other. And then I use the concept or the strategy of cross multiplying. So I'm going to multiply the 24 with the M, and I'm going to write the result of what that is down below it, which is 24M. And then I'm going to multiply the 108 with the 8. And I'm going to write down whatever 108 times 8 is. And once again, I'm doing this off screen on a calculator, 864. And then the idea is whenever 2 ratios are in proportion, after you cross multiply, you set the results equal to each other and you use algebra to solve. So I'm going to solve for M, and which is going to be the missing side. I'm going to divide both sides by 24. That means the 24s would cancel out, and I would get M is equal to 864 divided by 24, which is 36. So in example number 2, my missing side is 36. Okay, guys, there we go. There's your notes for assignment number 9, solving for missing lengths in similar triangles.